Hello everyone, I am Prashant Mahajan from All India Sri Shivaji Memorial Society's Institute of Information Technology, Department of Electrical Engineering. In this video, we'll be seeing how to calculate the count that needs to be loaded in timer for generation of the desired delay. For this, first we'll take a look at a 2-bit counter. So the possible states of a 2-bit counter are 0, 0, 0, 1, 1, 0, and 1, 1. So there are four possible states of counter. And suppose if we load the counter by a number 0, 1, then it will change its state from 0, 1 to 1, 0, from 1, 0 to 1, 1, and back to 0, 0. TF stands for timer overflow flag. So when the timer changes its state from all ones to all zeros, we say that the timer has overflowed. So here I have written timer overflow flag equal to 1. So if you load a number 0, 0 in the timer, then it will count 0, 0, 0, 1, 1, 0, and 1, 1. And then after 1, 1, it will go back to 0, 0. So if you increase this count to say 1, 0, then it will count from 1, 0, then it will go to 1, 1, and from 1, 1 to 0, 0. So in this case, the time required for the timer to overflow will be two states, 1, 0 to 1, 1, and from 1, 1 to 0, 0. That means that if you change the initial count, you can change the total number of state after which the timer overflows. Okay, so this is what is used in generation of delay. So more the count, initial count, the less the amount of time after which the timer overflows. So again, I'll just repeat the total number of states which are counted. So if you load the timer by 0, 1, it will count 1 state, 2 state, and 3 state. So after 3 states, the timer will overflow. If you load the initial count as 1, 0, it will overflow after 2 states. So the timer overflow will take place after 2 raised to 2 because it's a 2-bit timer, therefore 2 raised to 2 are 4 states minus the initial count. So if the initial count is 1, which is in this case it is 0, 1, so it will overflow after 3 states. Those 3 states are, this is the first state, second state, and third state. Okay, so if you want the timer to overflow after 3 states, you have to load a count equal to 1. So if you want the timer to overflow after X number of states, then the initial count that needs to be loaded in the timer is 2 raised to 2 minus X. Okay, so this is the basic thing that you'll require in timers. So this is a block diagram of a general timer. So the oscillator frequency is internally divided by 4, and whatever frequency you get is again divided by a prescaler, and the timer will work at that particular frequency. So oscillator frequency divided by 4 divided by the prescaler value is a frequency at which the timer works. Prescaler can be kept equal to 1. So if you don't want to divide it by a prescaler, you can keep it equal to 1, or you can bypass the prescaler as well. So this we've already seen. When the timer changes its state from all ones to all zeros, we say that the timer has overflowed, and then the timer overflow flag is set. So this is the timer overflow flag. sorry. So first, if we want to find out timer frequency, uh, to calculate timer frequency, we need to know the oscillator frequency. You have to divide it by 4, which is this you cannot change. It's an inbuilt value which is used, and then you have to divide the frequency by the prescaler as well. So first, we have to find out what is the timer frequency. Once the timer frequency is known, then 1 upon timer frequency will give you the timer period. Now, what a timer period means is that this is the amount of time required to count one state. So, TP is the amount of time required to count one state. So, if TP corresponds to one state, and suppose you want to find out a delay, uh, then a delay of say x milliseconds or a delay of some milliseconds. So, if TP corresponds to one state, this amount of time corresponds to how many states. So we have to find out how many states will correspond to the required amount of delay that you are planning to calculate. Therefore, x equal to delay by the timer period. So once you get the x, that means you know these are the amount of states. If the timer counts these number of states, then we can be sure that this delay will be required. So that means the timer will require this amount of time, that is delay time. Okay, so if it counts x number of states. So the count that is to be loaded in timer is 65536 minus x. Here I have assumed that the timer is a 16-bit timer, so maximum number of states is 2 raised to 16. So 2 raised to 16 is 65536. So total number of states minus the value that you get by dividing delay by the timer period. So once you load the timer by this amount of count, it will start counting from that particular value, and when it overflows, we know that the required amount of delay has been uh, achieved, or required this time delay time is elapsed. So we'll take an example. Suppose we have to calculate what is the amount of count that needs to be loaded in a timer for generation of a delay of 5 milliseconds. We have assumed that the timer is a 16-bit timer. Therefore, the maximum count which it can count is 65536. Basically, it means that we want the timer to overflow after 5 milliseconds. Okay, so for calculation of count, we need to find out what is the value of count that needs to be loaded in timer so that it will overflow after 5 milliseconds. Because once it overflows, we can check the overflow flag and know that that particular amount of time is completed. That oscillator frequency is assumed to be 10 megahertz, and we have assumed a prescaler of 4. So first thing that we have to do is find out the timer period. Okay, so for that, the oscillator frequency is 10 megahertz. So in the previous slide, we have seen the oscillator frequency divided by 4 divided by the prescaler value will give you the frequency at which the timer works. Okay, so the timer will work at a frequency equal to 19531.25 hertz. 1 upon this frequency will give you the timer period. So timer period is equal to 1 upon the timer frequency is equal to 5.1 to 10 raised to minus 6 seconds. So to count one state, it requires 5.1 to 10 raised to minus 6 seconds. Okay. So if we plan to find out a delay of 10 milliseconds, so 5.1 to 10 raised to minus 6 seconds will correspond to one state. So 10 into 10 raised to minus 3, that is 10 milliseconds, will correspond to how many states? So we'll find out those number of states. So those uh, states, if we calculate that state, it comes out to be 195. Okay, that means that when this particular timer with a prescaler of 128 with oscillator frequency of 10 megahertz, if it counts 195 states, it will take 10 milliseconds. This is what is meant. Now, if for the timer to overflow after 195 states, what is the amount of count that needs to be loaded? So, if you load a number 65536 minus 195, which is 65341, in hexadecimal it is FF3D, then it will start counting from FF3D. So next count will be FF3E, then it will go to 3E, then 3F, and will continue to count. So after 195 states, it will roll from all ones, that is FFFF to 0000, and the timer overflow flag will be set. Once the timer overflow flag is set, we know that 10 milliseconds are over. Okay, so this is how you calculate the count which is to be loaded in a timer for generation of a specific amount of delay. In this case, the delay is 10 milliseconds. Okay, thank you.